Okay. Oh, come on now. Thank you. All right. So we are looking at questions 13 and 18 pretty much. So let's take a look at 13. Arr, where's my... Finally. Okay. 13. 13.
Is it long? Do I get it?
Right when it's long. What is it?
I have this one.
You can do it. I believe in you.
Okay, so what do we have? We have velocity is equal to, and this is a very suspicious looking antiderivative, e to the negative 2x cosine of, no, this is the wrong one.
Wait, no.
T.
It's t cubed
T cubed.
e to the negative t.
Ah.
T cubed e to the negative t.
I can't see it. It's your mouth.
Great. And for part A, find the antiderivative of v. Okay. A, antiderivative of v would be the antiderivative of t cubed e to the negative t dt. We're going to look at that, and we're going to, first of all, just think if we can use a substitution method or simplification. No, we can't. All right. Next, we're going to take a look and see if we can use ultraviolet voodoo.
Yeah, the tabular integration first.
But it looks so. Check to make sure if we can use that tabular method. Is our u, what is our u here going to be? Okay, so t cubed is going to go to 0. E to the negative t, we can take integrals indefinitely, so we're good.
Oh,
Okay, so we have u is t cubed. Again, I'm using t cubed because eventually the derivative of t cubed is going to get to 0. And we have e to the negative t. I'm using dt, of course, but we're not putting that there now. We use e to the negative t because we can take integrals of that indefinitely. Okay, so derivative is 3t squared. Integral is negative e to the negative t. Derivative is 6t. Integral is e to the negative t. Derivative is 6. Integral is negative e to the negative t. Derivative is 0. Integral is e to the negative t. Okay, let's put this together. The first one we have is positive, so it's negative t cubed e to the negative t. Next one is also negative. It's now negative, so minus 3t squared e to the negative t. That negative came from right here.
oh,
Okay, the next one is plus 6t times the negative, so minus 6t e to the negative t. Last one is subtract 6e to the negative t And of course we have constant. All right, looks like every term is negative, so I'm going to factor out a negative. Every term also has an e to the negative t, so I'm going to also factor out an e to the negative t. Great. Let's see what's left. T cubed plus 3t squared plus 6t plus 6 plus constant. I think that's it. I think the only thing left to do is to put that e on the denominator because we're not supposed to have a negative exponent in the final answer. That looks good. Yeah. Yeah.
Okay, so how do you know, like, when you absolutely, like, when you could possibly do the tabular and substitution, and which one's better?
Always pick substitution if you can do substitution, always pick substitution. Okay. If you are going to use the integral by parts, you will probably use tabular method if your u is going to be an algebraic function. Okay. Okay, that's 13. No, that's part A. What's part B? Ooh, part B. Evaluate it from 0 to 4. Okay, so we're going to integrate from 0 to 4. VT dt. And that's just going to be my antiderivative.
This is a free response one, right?
Yeah. We're going to evaluate that from 0 to 4. Okay, so this is the fundamental theorem of calculus. Integral of the derivative is the difference of the function. Oh, that should be a positive. I don't know why that little line there is. That line needs to go. All right, that's good. We have negative 1 over e4, 4 cubed plus 3 times 4 squared plus 6 times 4 plus 6 minus negative 1 over e0, 0 cubed plus 3 times 0 squared plus 6 times 0 plus 6. All right. Negative 1 over e4. Let's see, 4 cubed is 4, 16, 64. 16 times 3 is 48. 24. 6. This is a 1. And that's 6. Almost done. Let's see. 30, 78, 122, 142. 142 over e4. Okay, that means the integral from 0 to 4 of VT dt. Let's see, I can actually put this in a common denominator, right? If I multiply this by e4 over e4. That gives me 6e to the 4th minus 142. The entire thing is over e to the 4th. There we go. That's part B. Part C. Compute the average value. Okay, the average value of the velocity is 1 over 4 minus 0 times the integral from 0 to 4 of VT dt. You know what I want to do? I want to move that over. And I want to write average equals. All right, so that's just 1/4 of
6e to the 4th.
let's see, 3e to the 4th minus 71 over 2e to the 4th. That takes care of number 13. Hey, this is not that bad of a question. No. Look how it ties together the previous chapter too. That's kind of cool. Last one, question 18. All right, dy dx equals y plus 1. F of 0 equals 3. And y equals f of x. Supposed to integrate this. Okay, step 1. Separate variables. Remember, separate variables will most likely mean divide and multiply. It's almost never add or subtract. Okay, let's take a look at the left side. The left side, we have the integral of dy over y plus 1. I'm not going to take for granted that you know that you're to do this. du equals dy. So this becomes the antiderivative of du over u, which is the natural log of the absolute value of u. So it's equal to the natural log of the absolute value y plus 1. That's great. That's the left side.
Why do you want dx by itself instead of dy?
You need to, the idea here isn't to separate one thing from the other. It's to keep all the x's on the right side, keep all the y's on the left side. Separate the x's from the y's, not to solve for one of them, one or the other. Right hand side, integral of dx. And a constant. So in other words, if I take the integral of dy over y plus 1 equal to the integral of dx, then I'll get the natural log of y plus 1 equals x plus a constant. Yeah.
Can you scroll up a little for a second?
Sure, I'll pause it too. And we pause. And we take attendance.
That's not cool.
That's the answer.
No, we're not done. I'm just taking a break so I can take attendance.
Is the next thing we're gonna do through show that we don't need the actual values?
I'm sorry? I'm taking a break so I can take attendance.
I'm here.
You are here. And I just clicked into period 6 instead of period 5. You're period 5. Don't you forget it. I think this is the year we finally make calculus. What do you think, t-shirts or sweatshirts?
Sweatpants.
Sweatpants? Oh my god.
Pajama pants.
Calculus pajamas.
Wristband.
Calculus pajamas.
Pajama pants.
Pat,
Bands.
Pat, let's ask people what they mean. Sauce.
You already say what it is.
Susie, what? What's the Miko meaning?
I don't know.
I'm not in the
Needs to pick it.
Susie, are you
sauce. No.
Did you get promoted?
For secrets out, it's okay.
Is
Is he okay?
Okay,
Maybe not.
next step. Let's check to see.
Hi, Laura. And then she's like, hey, Laura. Ugh.
Thank you for reaching out.
Calculus
Laura,
PJ. I assume you mean bottoms, right?
Yeah.
PJ pants.
PJ pants.
no, she's not. Okay, end of
No,
discussion.
I really want calculus PJ pants.
When's your photo?
We should have mugs.
Be quiet, Laura.
I'm going with the PJ.
Oh my god.
All right. What's our initial condition?
F of 0 is equal to 0.
0,3.
All right. So check absolute values. Okay. Our initial condition is 0, 3. So we have the natural log of. Sorry, the absolute value of 3 plus 1 equals 3 plus 1, right? That means the absolute value of y plus 1 is just equal to y plus 1. So we don't need the absolute values. Natural log of y plus 1 equals x plus c. Now we exponentiate Don't forget, you're always going to want to put e to the c as a multiple off to the side.
Why is it plus E? It shouldn't be plus E.
Times e to the c. Right, that gives me y plus 1 equals a e to the x.
Wait, you made E to the CA.
Yep.
Oh.
Finally, y is equal to a e to the x minus 1. That's my particular solution. That's totally wrong. This is the general solution. General solution. Lastly, we're going to use our initial condition again. 3 equals a e to the 0 minus 1. And we'll get 2 equals a.
Is it 4? 4.
4 equals a. I can't add.
Then y equals 4 x minus 4.
And that's a particular solution.
I don't get what just happened. Tell you, I just don't understand what's happening.
Grab like
Do you want me to tell you my
Let me turn this off.
Usually those have a knife and a grab bag.